So where's the problem? Would the PCB blow up or go haywire? If we wear these gloves, does that make it safe for us to touch electricity, or do we need rubber gloves, the same as car mechanics? If anybody knows, can they leave them on the comments below? And if you've got any comments on the video suggestions, please leave a message there for me as well. So first, of the 4 parts, we're going to skip the first 3 because that's in ohms and DC, and that's on another video which I've made earlier. So today we want to concentrate on the mains 230 volt side. If we have voltage on the brown wire and also on the blue, will that affect the motorized valve, whether it's a mid position or a zone valve? That's the question, and we'll find out shortly. So the first part that we're going to do is to make sure that the programmer is in the off position, because we don't want it firing up as we're working on it, because obviously that's going to be extremely dangerous. The next thing we're going to need to do is to turn the power off, either the spur, remove the fuse, or unplug it and make sure it's safe. And don't forget, we need to use our non-contact pen to make sure that off is dead. So the object of the exercise is simply to find out by using our multimeter on AC where the voltage is, where it isn't, and how much. So the first part of this test is going to be the live and neutral connections. So as always, we'll put the multimeter onto volts ACs, so that's the wavy line, and we always put the black lead and put it into the neutral first, and then the red lead goes into the live terminal, and we see minimum of 230 volts. The second test is to divide the voltage from the earth. So we'll put the black lead onto the casing, but not the white casing because that's insulation, the bare metal one, or where you see the yellow and green wires go to a point, the earth point or the chassis, anything that way. So the black lead goes there, and then the red lead goes to the live terminal, and we read off minimum 230 volts. So that tells us that terminal is correct. And the final phase of this test is going to be earth to neutral terminal on the PCB. And here we have to have no volts, 0. If we get 1 or more volts, that will affect the workings of every component that uses voltage. The pump, the fan, the gas valve, and of course the PCB. Here's a drawing from those brilliant people at Worcester Bosch. It's all about reverse polarity, so you can quickly check the different tests that we have to do. It just confirms what we've already done. Going back to our test between earth and neutral, and we found 1, 2, 3, 4, 5 volts. A lot of people are taught incorrectly that that's okay. We can have 5 volts going up the blue, nothing will happen, it's perfectly fine. That's really wrong. There mustn't be any volts going down the blue. And this is the effect that will happen. You will get an error code from the pump and it will say replace. There's nothing wrong with the pump. Or the fan, or the PCB, or the gas valve. You'll get lots of error codes and they're all completely wrong. If you'd like to find the fault as a gas safe engineer, you've got no chance. You have to be Part P registered who has done the course on this very fault. It's a very big fault. It happens a great deal around houses and people don't realise that because it doesn't affect most appliances, but it will affect our boiler. So first of all, as we can see, the customer has to find a Part P electrician. We don't get involved. We don't recommend anybody because that makes us liable, and we're not allowed because the insurance company strictly forbids us to recommend anybody to do anything. It's a customer fault, it's a house wiring fault, or a house product fault, one of the appliances. The number one appliance that seems to cause this fault is the fridge freezer. Something happens to the motor. I don't know why. I've just asked lots of very high class and extremely good electricians, and they all seem to say the same thing. The fridge freezer is number one culprit, then the fridge, then the freezer, then the washing machine, then the dishwasher. So it's all those things connected with water. Something there, I don't know. If you do know, can you leave them in the comments below? Because we'd all like to share, and also how you can fix it. When you download the app, the F22 error codes, fault codes, you can now test and see whether that pump or that fan, that component is actually faulty with the manufacturer's information. And you can always phone from the app directly to technical and then ask them for guidance about the sequence of testing. We have a special offer at the moment. If you buy both books, it just costs £40, includes postage, no VAT, and it's available to UK postcodes only.